It is a decarboxylative amination reaction. Decarboxylative amination. Decarboxylative amination reaction. That means here removal of carbon dioxide and addition of ammonia takes place. Amine group. What is this Schmidt reaction? What is the useful of this reaction? Means this reaction is useful for the conversion of carboxylic acids to amines. Carboxylic acids to amines. In this Schmidt reaction, carboxylic acids on reaction with hydrozoic acid. Reaction with hydrozoic acid. Hydrozoic acid produce these hydrozoic acids in the presence of concentrate H2SO4. One of the intermediate hydrox acid azides are formed. These intermediates rearranges in acidic medium produces primary amines. Primary carboxylic acids reaction with hydrozoic acid in the presence of concentrate H2SO4. What is primary amines are formed? This reactions proceeds through a intermediate called acid acyl azides. Again, you can observe the mechanism of this reaction. In the first step, what happening here? Formation of acid azides are formed. Formation of acid azide. Carboxylic acids on reaction with hydrozoic acid, removal of water, H2O, removal of water. Acid azide is formed. Acid azide. The next rearrangement. These acid azides rearranges to form alkyl isocyanates. What happening here? Here the negative charge on nitrogen is shifted to carbon and nitrogen. The alkyl group on carbonyl carbon is rearranges to nitrogen and loss of nitrogen. Loss of nitrogen or N C double bond and C double bond O. This is alkyl isocyanate. On hydrolysis of this alkyl isocyanates, hydrolysis of alkyl isocyanates give primary amines or NH2. This reaction is called, what is this? Schmidt reaction. For example, you can write the number of examples. For example, I am write, for example, acetic acid, CH3COOH, CH3COOH plus hydrozoic acid, N3H. The presence of concentrate H2SO4, concentrate H2SO4. What is the reaction product is CH3NH2 methylamine plus N2 plus CO2 gas. You can write number of examples. For example, CH3 toluene and COOH. Paratolic acid, paratolic acid, paratolic acid plus hydrozoic acid N3H, the presence of H2SO4, H2SO4 and chloroform CHCl3. CH3 here COH group will convert it into NH2 group. NH2 paratoluene, paratoluene is formed. This is Schmidt reaction. Next to Hunsdieckar reaction. Carboxylic Hunsdieckar reaction. Hunsdieckar reaction is also called as decarboxylative halogenation. Decarboxylative halogenation. What happening in this reaction means carboxylic acids are converted into carboxylic acids or carboxylic acids to what is the product alkyl halides. Carboxylic acids to alkyl halides. What happening in this reaction means heavy metal salts of carboxylic acid, heavy metals like mercury, silver, lead, heavy metal salts of carboxylic acids. Heavy metal salts of carboxylic acid. I am taking here silver carboxylate ion. Carboxylic acids reaction with bromine or iodine in the presence of carbon tetrachloride. In the presence of carbon tetrachloride gives alkyl halide. Alkyl halide. This alkyl halide is having one carbon less than the starting carboxylic acid. The alkyl halide is having one carbon less when comparing with the starting material. In this reaction, carbon dioxide is removed and halogen is attacked by or halogen is take its position. And that's why this is called decarboxylative halogenation reaction and is known as Hunsdieckar reaction. In this reaction, what happening here? Carboxylate, silver carboxylate ion. In the presence of silver carboxylate, in the presence of silver carboxylate bromine ion reacts to form what is the one intermediate ion is formed. These intermediate undergo homolytic cleavage in between oxygen and bromine, two electronegative atoms. Oxygen and bromine. What is the two free radicals are found? Bromine radical and all carboxylate radicals are formed. These carboxylate radical again undergo homolytic cleavage and form alkyl radical and carbon dioxide. Here loss of carbon dioxide is takes place. This alkyl radical again reacts with this bromine radical and form alkyl bromide or alkyl iodide. For example, you can write number of examples. For example, I can write C6H5. For example, C6H5 CH2 COO minus Ag plus silver phenyl acetate plus bromine, silver phenyl acetate plus bromine in the presence of carbon tetrachloride and heating at 75 degrees centigrade temperature. What is the product? C6H5 CH2 Br C6H5 CH2 Br, that is benzyl bromide. What is this? Benzyl C6H5 CH2 Br, benzyl bromide is formed. This reaction is a Hunsdieckar reaction. Next, Blanc reduction. This reduction is nothing but esters into alcohols. What is this? Esters to alcohols. The reduction of esters into alcohols with sodium alcohol as a reducing agent. Sodium alcohol as a reducing agent is known as Blanc reduction. The advantage of this reagent is it does not reduces double bonds. It does not reduce double bond. For example, you can write CH3, CH2 taken 7, CH double bond, CH, CH2 taken 7, COO, CH3. This is called methyl oleate. In the presence of sodium and alcohol, sodium and alcohol. What is happening here? Only that this COOH group will be converted, but it cannot be affect the CHC double bond O group. Here C double bond O group is there. Here just the product is formed like this: CH3, CH2, 7, CH double bond CH, CH2, 7, then CH2, 7. And what happening here? Only CH2 OH plus CH3 OH. Here this double bond is not affected by this reagent, sodium alcohol reagent. The next reaction is arndt eister synthesis. This is very interesting reaction, arndt eister synthesis. In this reaction, acid is converted into acid, but one carbon increases. One carbon increases. That means this reaction is very useful for preparation of higher homologue of an acid. Higher homologue of an acid. What happening in this reaction? First of all, carboxylic acid is converted into acid chlorides by reacting. First, carboxylic acids are converted into acid chlorides by reacting with thionyl chloride. This acid chloride reacts with diazomethane. Diazomethane gives diazoketone. This diazoketone on reaction with silver oxide in the presence of water gives carboxylic acids with one carbon higher than starting one is known as Arnold Astor synthesis. Carboxylic acids SOCl2, CH2N2, Ag2O, H2O. What is the product is carboxylic acids. Arnott ester synthesis carboxylic acids to carboxylic acids, but the strength chain of the carboxylic acids are increased. In this mechanism, in the first step, carboxylic acids are reaction with thionyl chloride, it form acid chloride or COCl. The second step, this acid chlorides reaction with diazomethane and form alpha diazoketene. Alpha diazoketene. Here diazomethane in diazomethane CH2 is having negative charge. This negative charge donates electrons to carbonyl carbon and loss of Cl minus N. This carboxylate acid chloride remove one proton to form alpha diazoketone. Alpha diazoketone. This alpha diazoketone on heating with silver oxide, alpha diazoketone is eating alpha diazoketone on heating with silver oxide rearranges to ketene. This on hydrolysis gives carboxylic acid. Here also alpha diazoketene rearranges means here the negative charge donates electrons to the C double bond O and C. Alkyl group rearranges to attach to CH carbon and loss of nitrogen is takes place. Loss of nitrogen. What is happening here? Ketene or CH double bond C double bond O. Ketene on hydrolysis of this ketene. What is or CH2 COH. Here only the one carbon is the one carbon increased. For example, CH3 COOH, CH3 COOH. What are the reagents we are using? Thionyl chloride, diazomethane, silver oxide, and water. Silver oxide. What is the product? CH3 COOH acetic acid. Only one carbon increases. CH3 CH2 COOH. CH3 CH2 COOH. That is propanoic acid. And the next one, HVZ reaction. HVZ, Hell Wohlhard Zelensky reaction. Conversion of aliphatic acids to alpha halo acids. Conversion of aliphatic acids to alpha halo acids. Aliphatic carboxylic acids on reaction with halogens in the presence of red phosphorus. Carboxylic acids reaction with halogens in the presence of red phosphorus gives alpha bromo or alpha halo acids. Is this reaction is known as HVZ reaction. Or CH2COH plus Br2 in the presence of red phosphorus or CHBr plus COH alpha bromo acetic acid is formed. For example, I am taking CH3COH. This carbon is the alpha carbon. This alpha carbon is having three hydrogens. Remember it. CH3COH plus Cl2 in the presence of red phosphorus. One of the alpha hydrogen is replaced with chlorine CH2Cl. Here two hydrogens are present. This chloroacetic acid again reacts with chlorine and form dichloroacetic acid. Dichloroacetic acid. This dichloroacetic acid again reacts with chlorine and the presence of red phosphorus. It gives trichloroacetic acid. Trichloroacetic acid. This reaction is called, what is this? HVZ reaction. In HVZ reaction, carboxylic acids to alpha halo acids are formed. Then Hoffman hypobromite reaction. In Hoffman hypobromite reaction, acid amides are converted into primary amines. Acid amide. What is this? Acid amide. Acid amides to what happening here? Amines. Amines. Acid amides to amines. In acid amides can be converted into primary amines. Primary amines with the loss of one carbon atom. With the loss of one carbon atom by the action of halogen. By the action of halogen in the presence of sodium hydroxide or potassium hydroxide. For example, acetamide in the presence of bromine in the acetamide reacts with bromine in the presence of sodium hydroxide give methylamine. Methylamine. For example, bromine. You can observe this mechanism. Bromine in the presence of alkaline medium, what happened? Hypobromite ion is formed. Hypobromite ion. This hypobromite ion reacts with acetamide or CH3 C double bond O NH2 plus hypobromite ion O minus Br. O minus Br. This reacts to give one intermediate CH3 C double bond O NHBr loss of OH minus CH3 C double bond O N minus Br plus H2. This CH3 C double bond O N Br rearranges means nitrogen donates electrons to carbon skeleton and methyl group is shifted to carbon to nitrogen. Methyl group shifted from carbon to nitrogen and loss of Br minus, loss of bromide ion. What happening here? Methyl isocyanato intermediate is formed. Methyl isocyanato. On hydrolysis of this methyl isocyanato will produce methyl amine. Methyl amine. This reaction is called as Hoffman hypobromite reaction.